we'll get started then. Many thanks to you all for joining today's webinar. I'm going to be discussing today using artificial intelligence to manage BRCGS Issue 9. Now, clearly, artificial intelligence has had a lot of press recently, so we're not going to be putting anyone out of a job today by saying AI is going to manage everything. But what I do hope to achieve today is to show you a few areas where artificial intelligence can be used, particularly in the areas of risk management, HACCP, VACCP and TACCP, and a few other areas. So I'm going to run through some slides first, kind of do it like a bit of an introduction. And after that, we will look at a summary of the changes in BRCGS Issue 9. And this will not be a blow-by-blow account of the changes in Issue 9, but we do have a fairly comprehensive summary of those changes in the slide deck, which you'll be able to get a copy of later when we send out the recording. We will discuss the use of AI as well, and then we will have a short practical demo of how we have started to implement artificial intelligence in our 3i Verify solution, just to give you some ideas of how this can be used as a technology. And then at the end, we'll have a Q&A session. So please, during the presentation, everyone's muted. So please enter any questions into the chat box of the Zoom webinar meeting. And at the end, we will run through those questions and try and answer those questions as best we can. Okay, so let's jump right into it. So firstly, I'll give you a little bit of background about myself. So my name is James Flynn. I'm the CEO and founder of Primority. Primority is the company who creates and manages and updates our 3i Verify software solution, which is designed to help companies comply with GFSI benchmark standards such as BRCGS, FSSC 22000, SQF, and others. So there you have it. There's my background on the screen. I began my professional life as a water treatment engineer back in 1990 as a science graduate, and I've pretty much been involved in chemicals, food safety, and so on, all the way through to 98 to 2000, when I did a master's in software technology, and then began developing HACCP software and doing HACCP consultancy. I also spent a bit of time working for a very well-known, now bought over quality management software company. And when that changeover took place, I then founded Primority and began building out our 3i Verify system, which you'll learn a bit about today. From 2019, we went for some Innovate UK funding to work on AI and its application to food safety. And that's largely what you're going to see today, the results of that work. And we continue to work on artificial intelligence. And in fact, I'm going to show you some prototypes of the kind of work we've been doing on that using the now infamous ChatGPT. So you'll see a bit about that later on. Okay, so what my passion is using digitization to help make people's jobs easier. And hopefully you'll see indications of that as we go through the rest of today's presentation. So that's what really gets me out of bed in the morning, is working on tools to help technical managers, quality managers make their jobs easier. Getting people to try and ditch the spreadsheets is not as easy as it sounds, because people are comfortable with spreadsheets and so on because they know they work. But as I'm going to point out, spreadsheets are really not fit for purpose when you're trying to manage a fully integrated food safety and quality management system, and particularly GFSI benchmark standards as they become more and more complex and more demanding. So some of the companies that we work with, you'll recognize some of the names on here. These are mainly UK brands, but we also have a global import agent business which works with hundreds of US-based importers to help them with FDA compliance, for example. So we're really heavily embedded in the whole standards and compliance space, and everything we do with our software is all about helping there. So what's the problem we're trying to solve? This is the problem that most food businesses encounter on a daily basis. We call it the silo problem, and it is characterized by these different departments within a food business and with the supply chain, and the multiple lines of communication that take place between departments internally in a food business and also the suppliers and the supply chain. So every day we're working on the tools that enable that collaboration to be in a joined up kind of fashion. So the platform is really designed to help that collaboration piece and make sure that there's one source of truth and that everyone can work on the same information together, but also with the supply chain as well. So our approach is to look at the various elements of GFSI standards and bring those together in an integrated fashion, using tools that talk to each other and can communicate information and feed through, for example, in audits, through to non-conformities and corrective action records, and NCRs on suppliers and raw materials, and on quality standards and HACCP, and making this all digitized. It's not a trivial problem, however, and much of it is risk central. So in any area of a food safety management system, we're always starting with risk. It's a risk-based approach, be that HACCP, quality, food fraud, intentional adulteration, supply chain food safety, compliance, and so on. And we're going to be talking quite a lot about risk because this is one of the key areas where artificial intelligence can help us identify risks and then feed that into a food safety and quality management system so we can manage those risks effectively. So all GFSI standards and ISO standards need effective risk management at their very core. And this is something that I know that food safety, technical and quality managers wrestle with every single day, because it's a mammoth task. But there are three main problems with risk management. Or the top one is that there are many, many sources of risk information out there. And the second one that I'm sure you all identify with is that there is simply not enough time to gather, analyze, and manage risk-based information. And most of it's done in spreadsheets. So to manage risk effectively and efficiently, we need to solve these problems. And again, I'm going to suggest that AI can help with that. It's not the solution to everything, but I do believe, and I think we've proven that, it can help with that. So the root cause, as I mentioned, is too many data sources. But it's also siloed systems that don't talk with each other. And along the top line here, you can see the UK Food Standards Agency, the Food Safety Authority of Ireland, we've got RACCP from Europe, the Canadian Food Inspection Agency, you've got the US FDA, and then you've got Food Standards Australia and New Zealand. And one of the things that we discovered was that none of these guys describe things like food recalls and food safety risks in the same way. They've all got their own way of describing these things. And that makes it very difficult to have a standardized approach about how you get that information into your food safety system in order to inform it of new and emerging risks. So we'll look at those kind of things. In addition, there are many other companies out there who are focusing on individual aspects of risk management, be that Discernus, FERA, and others. And then there's certification bodies who offer various services there as well. And it has really become an industry in its own right just to get data. And to do that, you really need unlimited time and big budgets to get good, accurate data. The result is that most people use very large, out-of-date risk spreadsheets, and these themselves can become a risk because they're not automated, they're not pushing and prompting for reviews, and everyone's kind of left to their own devices to come up with their own methodologies of managing risk. So I believe that the use of spreadsheets is in itself a risk when just one unforeseen risk can cause a costly product recall or consumer harm. So we're going to talk about how we can solve some of that using AI. So far, I've mentioned various data sources. The kind of information which is in these data sources may fall into some of these categories. There are other data sources as well, of course, but the most easily accessible data sources will tell us about food safety recalls, allergen recalls, lapses in certification, import refusals and border controls such as RACCP and FDA, negative news out there on the internet, and also information that may be in corrective action records that you are logging regarding suppliers, internal processes, and so on. And we believe that all of these should be feeding into HACCP, VACCP, and TACCP in an integrated fashion. So we're going to look at that a little bit later, and that this approach equals a better way of doing food safety. Gathering the available risk information that's out there can help really identify what is a real risk, what's not a real risk, and also help inform you about the kind of risks that need to be assessed in your processes and in your management procedures. What is AI? So AI really falls into three very distinct categories. And the big circle on the outside, the artificial intelligence bit that everyone talks about, is really, in its simplest term, is a computer program that's got the ability to learn and reason like humans. And ChatGPT is a very good example of that. ChatGPT, for example, has been trained on all of the information that's out there on the internet, which is a lot of human knowledge. In that knowledge, there is good knowledge and there's not so good knowledge, and there is high quality knowledge and information and not such high quality information. And ChatGPT's main thrust with implementing artificial intelligence is to learn from all of that and try and work out what's good high quality information and what's not. To do that, it uses machine learning. So this is like a deeper level of artificial intelligence where you have, it says machines, but we're really talking about computers. These computers have got algorithms in their neural networks and so on, which enable them to learn and to do this deep learning that's required. So there's a lot of really, really powerful technology out there. I'm sure everyone's heard that even Elon Musk recently has been saying we need to stop at ChatGPT version 4 because if we go further than that, then there may be dangers of people using AI for bad things. Well, that's not us. We are trying to use AI for good things to make people's jobs easier and more accurate, frankly. But in a nutshell, AI uses mathematics, algorithms, and data, because we can't learn without data, to simulate human intelligence to solve problems. But it's very, very powerful because AI doesn't get tired. It works 24/7, and it's finding connections with things that Albert Einstein might find, but you or I might not. And that's why AI is potentially extremely powerful, but we clearly want to use that for good. So what kind of things is AI good at solving? What kind of problems can it solve? So things like detecting the names of suppliers and data sources, we found that it's very good at that. So we can identify a company name in a news article, and we can associate it with raw material names. We can identify food safety hazards. We can identify food fraud keywords. We can use this data to spot unusual trends, and we can provide early warning alerts. So AI potentially is very good at these kind of seemingly quite basic tasks. However, as I mentioned before, because AI works at hyper speed 24/7 with no holidays, no sickness, it can be a very performance enhancing tool that can save us a lot of time and help us identify and reduce risks. So our model, before we get to the BRC side of things, is like this. So we have data sources that we are daily pulling in data from, like RACCP, the Food and Drug Administration in the US, Food Standards Agency, and various other sources. And I think we've got 6 different data sources at the moment, and we will be adding to that as we move on. We've then built AI processing into that data source so we can read the information and make sense of it to identify hazards, companies, and food products. We then use that in our system to help assess impact through configurable risk models. And that helps you take and record action and put in place management systems that help make sense and manage these things effectively. So the key things that we can really help with, based on everything we've spoken about so far, is raw material risk assessment, for example, in the supply chain. You've got your HACCP processes. Then we've got VACCP food fraud, TACCP intentional adulteration as well. And we're going to show you how we can integrate all of these things in one approach to food safety management a little bit later. So it gives us a lot of actionable and usable information to enhance the overall system. Okay, on to the BRCGS updates and changes. As mentioned, I have no intention of going through all of these bullet point by bullet point, but what I wanted to do is just highlight. We've had a quick look through the changes in each of the sections of BRCGS 9, and the key point from a systems point of view is that, just looking at over some examples here, so food safety and quality culture, for example, has been included properly for the first time in management commitment, continuous improvement. These are all words which are been in the standard for quite a long time, but the fact that food safety culture is now interspersed throughout the standard, along with authenticity, for example, is quite a big change overall, because it's really saying that there's another area of activity that everyone is now required to put in place in order to meet the standard. So the food safety culture side of things has definitely been, over the last few years, a growing trend, and now it's kind of official, if you like, in terms of BRCGS. A couple of other points regarding, and I've highlighted these for a reason, because these purple shaded ones are specific areas I'm going to focus on when we get to the system, because this is where AI can really have an impact. But a lot of these things are documented procedures, which means yet more work for the technical manager, quality manager, food safety manager, and reviews of procedures, more training, more implementation, and more auditing of these things. So this is not getting less work, it's getting more work just to comply with this, which means whenever you got more work, you need better tools at the end of the day to help with that. So a few things on the food safety plan, because we are going to spend a bit of time on this. So, for example, control measures and monitoring procedures need to be in place for PRPs. Some people may have been doing that already, but if you're not required to do it prior to issue 9, then quite a lot of people may not have been doing that. These must be documented in the food safety plan, and the food safety and HACCP plan must be based on comprehensive information sources with a list of reference documents. Again, the better HACCP systems out there and food safety plans out there would have done this, but there might be quite a lot of people who have not done that, which means quite a big review. If you've got 50 products and HACCP plans, that's quite a big review to get that done. Again, tools can help with that. Some other areas down here that AI can help with: the need to identify significant hazards. So a lot of people have been using 3x3 risk assessment matrices for decades. We feel that's no longer enough. You need to be more granular, and you need to have rules around your risk matrices that help you to identify significance in those risk assessments. So we're going to look at that as well. Things like the use of one or more than one control measure for a particular hazard and possible cause combination, validation of PRP control measures, and critical limits to be included in the validation. So again, these are all really quite significant changes. If you've got a lot of products, there's a significant amount of work, additional work that needs to be done around these things. In the food safety and quality management system, some quite important points in here: NCR results to be included as part of the management review, which wasn't quite that same text before. Some changes there. Authenticity is now appearing, throughout the standard in terms of requirements for supply and raw material approvals, and then ongoing performance reviews based on risk. And again, our experience of that is that it's not a trivial task. It's one particular element there, and we've been working hard to build out tools that will assist with that. So the headlines here: food safety culture, authenticity, PRP control and validation, and root cause analysis are the kind of things which really jump out of sections 1, 2, and 3. So site standards, there's been quite a lot of specifics on site standards in terms of quite down in the weeds stuff like strip curtain maintenance and cleaning and so on, giveaway products, traceability, contractor approval, certified or written terms and conditions. So the whole list of things there. And then on product control, again, what we are seeing where AI can have an effect, particularly vulnerability assessments and knowledge of raw materials and the risks that come with those raw materials, and also the ability or the need to carry out annual vulnerability assessments or when new changes or risks emerge. Again, quite a few people may have been doing that over the years, but now it's formalized. Everyone now needs to do that, which means there's more work to do. On the process control side of things, it's mainly about changes to processes and various other parts there regarding things like the use of labels and handover between production lines and so on. So the headlines here, specifics on site standards need to be reviewed, NPD change management, for example, to assess the introduction of new hazards when there's changes to processes or formulations, vulnerability assessments, need for annual vulnerability assessments, and again, authenticity spread all throughout the standard. One of the things that really came to my mind when reviewing the changes for BRCGS Issue 9 was how much it is moving towards the FSMA model, the Food Safety Modernization Act model in the US, which I'm sure is quite a deliberate direction by BRCGS, given that there are approximately 10 times the number of food manufacturing companies in the US as there are, for example, in the UK. And BRCGS being the largest GFSI food safety standard, I think that's a natural move. So definitely becoming more US biased or centric overall. On personnel, again, there's some specifics there, but the biggest one is that all staff now need to be trained, for example, including agency and temporary staff, and a couple of, again, down in the weeds things like wearable devices like watches shall not be worn and that kind of thing. In terms of production risk zoning, this again is a big requirement on FSMA risk zoning. We've always had high care and low care and high risk and low risk and all that stuff, but there's a lot more formalized aspects to this now, including site maps, procedures for changeover between low and high care, low risk and high care, specifics like removable walls and battery charging come up quite a few places. But micro risks being the real big one that jumps out to me with each production zone need to be considered now, and there has to be a plan in place for all of that. And then finally, traded products, if you're trading products, is now requiring a food safety and HACCP plan for all traded products, as well as traceability in there. So that's the kind of snapshot of how the standard has changed. And later you'll get a copy of the rest of the presentation, which has got some screenshots on some of the things I'm going to look at now. But at this point, I'm going to now jump over to the software side of things and take you through a few areas of how we can use AI in particular. Okay, so a couple of key points about 3i Verify. So 3i Verify is a cloud platform. It's available pretty much worldwide now. We've got servers in the US, UK, Europe, Egypt, a recent one. Amaris Kana is on the call here today. He's a new partner in Egypt. We also have partners in Australia and New Zealand as well. So cloud-based system, I mentioned the integrated approach earlier, and therefore we've got modules in the system. It is a modular. You don't need to have everything in the system. So we've got supplier management module, got material management, including risk management. So we're going to look at that. Place for managing your product lists, customers. We've got a questionnaires module, which is a heavily used module for our system for doing supplier and raw material approvals. We've got a forms module for digitizing all of those Excel and paper-based forms that you have, corrective actions, tasks, document management and control, our new HACCP module, and then we've got various other kind of reporting modules here. AI scan, which is focusing in on your supply chain, in other words, your suppliers and alerts to do with raw materials. And then there's a traceability module there as well. It's the whole idea of this is that you can start with managing your documentation. So I'll quickly show you a little bit in there. So all of these documents that you're using as the basis for your food safety and quality management system need to be under document management and control. This is a requirement under BRCGS and just about every other standard. For example, metal detect procedure. Here's a document which is mapping out zones and so on. One of the additional requirements in the updated standard. So you can upload the documentation regarding your factory layout, and this can be annotated and run through approval processes, change requests, all of these kinds of activities. Another area that was mentioned in the BRCGS 9 was things like artwork approvals. I think I've got on here. Labels can be uploaded into the document management part of the system. Again, that can run through approval processes. You can manage annotations on here as well, so that people can collaborate on things that need to be changed on labels, etc. This is a real one that's going on right now in our global import agent business in terms of label reviews. So it's not just about documents, it's about artwork, it's about approvals, and it's about the processes that we want to go through there. And of course, these documents can be embedded in forms, digital forms that people are using to carry out, for example, metal detection checks. So you update the procedure here, updates automatically in the digital form, which people are then using to carry out those particular checks. So that's just a little bit about documents. It handles the approval processes and so on. So all of these new processes and procedures which are required under BRC can be added into the system and collaborated on in order to make sure that they are meeting the correct standard. So that's documents. Let's go look at forms. I'm just focusing on getting what I would call the day-to-day tool sets out of the way so we can spend more time on the AI stuff in a moment, which is what we're all really here for. In the forms area here, so helping with food safety culture, we've got food safety training. So these could be sent out to employees. They can watch them on their phone, iPad, whatever. And the way that we've implemented this is that what you're actually looking at here is actually a PowerPoint. This section here is a PowerPoint, and we are able to convert these into multimedia, which can then be surfaced in a form, which can be sent to an employee, and then an employee can run through and do a test, and in the background get a score. We talk about integration. So, for example, if an employee answers a question or they answer certain questions and they haven't demonstrated their knowledge in that area, you could add a corrective action there, make a note that that person needs to be trained on something or whatever. So that's one example of forms. Another example of forms might be like a GMP audit. So these GMP audits, you can create as many of these as you need. And in this particular case, we've got a scoring system here, and you'll see that there's been a photograph taken. So when it's used on a tablet type device or whatever, goes of water, click a photograph. When you click on that, when you tap this button, I'll just pick that apple pie one as an example. So that gets embedded in the report, and you might say, yeah, that's going to be a critical, and I'm going to add a corrective action. So that's automatically all pre-populated. And then here, I'm then able to choose who this is going to be assigned to, and I would pick some kind of action category, which is all going to be used in reporting. Give it a priority, a due date, and then indicate what's affected by that. So all of this can then feed into reports later on. So that's maybe another time to discuss that. But this one here is corrective action. So in the background, there are workflows associated with this type of action. And we can select the type of action, click add, and everything's linked through from the audit through to the actual action. And all of the list of actions is then associated with this digital form. And you can then go manage that and then look at what the process is for dealing with that particular issue. And you can imagine this can be used for customer complaints, all kinds of things that require a process instead of a bunch of different Excel spreadsheets or Word documents. So here, there's an investigation form associated with that task, which is going to require completion, some photographic evidence, etc. So the key point is that we have all the tools in here for digitizing documentation, digitizing forms, and being able to efficiently collaborate online to manage information, corrective actions, non-conformities, and these can be raised from anywhere. So that's just a little bit about forms, finished product specs, workflow. There's all kinds of things that can be done here to replace Excel spreadsheets and kind of manual processes. Okay, so we're going to get into a bit more of the AI stuff now. We could spend a lot of time working through all of this side of things. To start with, I'm going to begin in the raw material section, because this is where we want to be doing raw material risks. Now, when we're looking at risk for particular materials from suppliers and manufacturers, then there's a number of key elements that we're going to be interested in. We're going to be interested in the rating of the manufacturer overall. We're going to be interested in the allergens from the MAQ, and all of these can be done in the supplier or raw material questionnaire. They can actually be embedded straight there, and the supplier can actually complete these, although we recommend that you approve them. We've got a couple of points here. This is an example of a manufacturer risk assessment, and this is a criteria-based risk assessment. Much of the risk assessment work that's done by the food industry tends to be risk metrics based, but there are certain things which just don't fit with that. Therefore, we've got alternative approaches. And what you're seeing here is a list of areas of assessment and a list of criteria. If I just do a new assessment here, you'll get the idea of how this works. So we've got some scoring criteria, and then everything's configurable here. You set this all up in the admin area, and you answer your questions. It's going to give us a score, and that score is going to be compared with this risk scoring up here. And of course, we get an output at the bottom here, where this one is going to be medium risk, and it will tell us some configurable action that we want to take. So we've got the concept of an assessor and an approver. I'll just quickly do the assessor process here. So we have locked out the actual assessment part, having done that. And then now someone else, in this case, I'm both an assessor and an approver. Someone else can come along, they get an email notification, and then do the approval, make any notes, and then run the approval like so. So I'm just going to do this one. Don't want to get too bogged down with details at this point. So that's a new risk assessment. We can create a PDF for that risk assessment and download that. We get a printed version of that about that manufacturer, which we can then share with other people, and then we can review that over time as we move on. There's a full history of every risk assessment that's been done here, and you can click into these and go see what was done and said and recorded at that point. So that's a manufacturer criteria scored based risk assessment. This one here is a new approach to allergen risk assessments. And when we designed this, we worked with a few of our core customers to come up with what we think is a more streamlined approach to doing allergen risk assessments for raw materials for individual suppliers. Again, you see there's a scoring system here, and we've got a list of allergens, and there are 6 criteria in this example. And again, all of this is configurable. So it's not present in the product, we give them a score of 1. The product is the allergen, gets a score of 2, and so on. This will then be compared with the overall scoring system. And again, all of that is configurable, and it will come up with a number at the end of it, which represents the allergen risk of this material. Now, we are going to alter this slightly because we do have in the background, we've got minimum control required, and we're also going to have an assessment whereby we validate the supplier's control or mitigation procedures and processes, and that will alter the score to bring it in line. And you can see you can upload details there as well. So you've got that type of scored risk assessment. We then have the kind of more standard risk matrix-based assessments: chemical, micro, physical, radiological, and intentional adulteration. You can configure what you need here, and you can set weighting factors there as well. So I'll just show you an example in here. So I'll pick a radiological. For these risk matrix-based assessments, this is where we are adding in data that's come from AI, for example. So in this particular case, it's a risk matrix-based scoring system, color-coded, etc. And you'll notice we've got this here, risk significance. There's a new requirement in BRCGS Issue 9 where they're requiring you to assess if a risk is significant or not. And in this case, we're saying we've defined that for this risk matrix as being less than or equal to 12. So in this particular case, anything that's 12 or less is going to be significant. If it's more than 12, it's not going to be a significant risk. You can add in hazards and risks, and these ones have come from our AI-generated database. And so we can add in those risks. I'm selecting those three, and if what you want's not there, you can add more in down here, but I'll just pick these three. So the risk assessment can now be conducted, and you can see the score coming through based on that matrix, and so on here. You can flag a risk as inherent or not, which can be used elsewhere in the HACCP, VACCP, TACCP side of things. And then over here, you have a list of controls. Again, all of this is curated by AI, but if your control you want isn't there, you can add it. The same thing down here, the identification of the place of control is another important aspect, particularly under PRISMA in the US, which is, I mentioned earlier on, this is where this is all headed. And we're definitely going to be harmonizing the approach to food safety in the coming years. And they use place of control in the preventive controls food safety plan to identify who and where the control actually takes place. This type of approach would be something like this, and just for speed, I'll just do approve all, and we'll process this as an approved risk assessment just to show you how that works. But the key point is that in the background here, we already are starting to see artificial intelligence coming through with a list of potential hazards and risks that may be relevant for radiological, for example. So from that, what happens is, you'll notice this is going to change now. These numbers along here, the top left one is the actual risk number as a percentage of each assessment that's been done. And that is then using the weighted calculation in the configuration here to come up with an overall total score. That total score determines what the management activity needs to be it an annual on-site audit or an SAQ every 2 years or whatever. And all of that is configurable against that score as well. Using this approach, we can get a really comprehensive, fully auditable record of risk assessments with reminders and approvers and other aspects of risk that is just not possible to do effectively or efficiently using an Excel spreadsheet, which is the way that most people do this type of activity at the moment. And behind all of this is this AI-generated information. Over here, we've got food fraud as well. I'll just pick one that's not been assessed to show you a little bit about that. This is also a scored criteria risk assessment, whereby you can set up your scoring criteria, your own questions and scoring for various different categories of the food fraud risk assessment. So supply chain, ingredient controls, etc. You can see it all there. And here, we have a number of assessment areas. You can put in your scores, so on like so. And again, it's going to compare that with the overall scoring. We then complete that for the whole thing. I'm not going to do it because it's a really big risk assessment. Run our assessment, run our approval. And again, that feeds into the overall score for that supplier material and if there's a third-party manufacturer involved. One thing I haven't really mentioned is that these are scoped. So for example, if it was pesticides and you wanted to do the same risk assessment against all pesticides, then you can categorize the material or you categorize the scope of that material for pesticides. And whenever you do a chemical assessment, it would do it for all of them, for example. You can also do it for manufacturers. So for example, you'll see here, I've got the same manufacturer here and here. They've both got the same score. So I just need to assess the manufacturer once, and whatever that manufacturer is, they will get the same score, which will then feed into that row of risk data. So there's a few subtle things in here which make this actually a very efficient way to do it, because once you've set up your materials and risk categories, you can very quickly get through a large number of risk assessments at the same time, rather than having to do them all individually. These risk assessments we've done here will then feed through into the HACCP module. And when we call it the HACCP module, it's a lot more than that. It's really bringing together raw material risk assessments, HACCP, VACCP and TACCP, along with prerequisite program management, a whole bunch of other parts to that as well. So back at the home menu now, going to the HACCP side of things. So here is where we really start to bring together a lot of the risk side of things. I'm just going to pick this one. I was in here earlier today. The starting point really about HACCP is identifying the scope of the actual HACCP plan. And if I just edit this one up here, you'll see what I mean. So in here, the scope of this HACCP, VACCP, TACCP plan is raw material risks, process risks, intentional adulteration, and food fraud. You obviously don't need to do all 4 of those, but it does actually make a lot of sense when you look at it. Things like company information, HACCP teams all defined, and intended use, which is another change in BRCGS 9. They wanted more specific intended use, including the expected uses to be defined for this. So we create the plan. We've got a drag and drop process flow diagram tool. And I'm just going to drag this in to show you an example of how this works. So if I do this as 2.2, I'm going to just call it private storage, just as an example. And to show you how this works, I'm going to now go do the hazard analysis for this. And in the background, we've got this AI curated database of operations, right? So we didn't call it process step types because we can apply this to the supply chain at any stage, or even internal processes that are not HACCP related. We've got all of these different things which may happen. You'll see there's stuff in here for crops, there's stuff in here for transport, for conveyance, etc. But the general principle is you select the operation this process step fits with. I'm going to pick material handling, intake, goods in and receiving, put a description here, and then we apply this process step. So which products? I know I've got some raw material risk assessments for sausages and burgers, so I'm just going to put sausages and burgers, and you can add products on the fly as well. And then the next stage is we move on to hazards. So in the hazards area, immediately you'll see that the raw material risks that we did in the raw material area have been pulled through, and we can see here this might be a raw material risk, so we'll accept that one. So on the left we've got possible risks and hazards, on the right we've got the ones we want to assess. So these have already been risk assessed, so I can pull those in. Some of those might be inherent hazards, for example. That's raw materials, so we'll start by looking at raw materials. The next part is we look at process hazards, and again these are already curated, so we've got a whole bunch of hazards here which are relevant to a chilled process step, for example. I can search this for temperature, for example. So bacterial growth due to excess time and temperature, maybe. Bacterial growth, temperature not low enough. You can see, you can pick the same hazard, but a different cause. We can quickly get through this. But this is the interesting thing. These are all curated already by AI, by our system on a daily basis. That's being updated. And the key point is that people using the system are also curating, because you can add hazards, you can add possible causes and controls. And this is where we can also go to ChatGPT. So that's what this is. This little button here, we can look for the system to suggest hazards for a given process. So you might say, well, cleaning brushes, what hazards might be relevant to cleaning brushes that are related to, for example, allergens? What this is doing now is it's going out to AI live right now, and it's going to say, well, allergen cross-contamination through the use of shared equipment, inadequate cleaning, blah, blah, blah. All of that came from ChatGPT in seconds. Let's do another one. Let's look at, say, physical. What physical hazards could be for that particular step. Again, ChatGPT, foreign material, broken or damaged equipment, etc., etc. There's a list of those. Let's go for microbiological now. And so I think you can start to see the idea here is that using live AI to go out there and look at the sum of all human knowledge to do with food safety and hazards and things that can cause problems means that we can quickly get through a hazard analysis and look for potential issues that we might not have thought about and that we might want to assess and include in our food safety plan. Fungal contamination, musty old brushes and cloths, for example, that could be a way that that could happen, and in the wrong circumstances could cause a problem. So we've got those kind of tools. The TACCP side of things, again, the system has suggested, based on that operation type, the kind of things that we might want to assess for intentional adulteration risks. So we've got some of them. Let's go do some food fraud. It might be corrupt staff, might be a fraudulent supplier. Okay, so we've got a couple of those. Let's go look at control. Come through the control. So the raw material risks are already being controlled, and that's already been done via the raw material risk. We're just pulling these through here. Let's go look at HACCP. So the control is over here. It might be minimum time out of chilled storage for that one, for example. This one here, effectively operating chilled storage, and I'm just approving these so I can take them through to the risk assessment next. First in, first out procedure. Let's go to TACCP, visually inspect equipment, conduct periodic checks. And again, at any stage of what you want as a control isn't there, you can add it very easily, and I'll add that in here and into your private knowledge base. Now, this is where we get to the significance threshold again. So we're going to be using a particular risk matrix here where the hazards and controls now come through to the risk part. And here, I'm just going to select some random. So that is a significant risk, whereas this is not a significant risk. And we need to put a justification in here, but the key thing is that if you've got your matrix set up correctly with a significance threshold that is suitable, then the system will work out for you right there and then if it's significant or not, and document all of it. Let's look at intentional adulteration. Again, this has got a different risk matrix for intentional adulteration, which again is all configurable. And so again, we've got a significance threshold of less than 10. So this is a significant risk. Put the justification in. Then let's now go through to the CCP determination. So we're working along these tabs, and then the information is being pushed along. And now we've got a decision tree option. So we can just go ahead and do that. And I'll just do a quick example. We'll say that that one's a CCP. Maybe I want to edit that, make this one a PRP. So I'll just say it's managed by prerequisite programs. So that's a PRP. And now we need to put a PRP in place. So this might be staff training or whatever. You can add your own list of PRPs here. I'll just select that one. So for the TACCP side of things, there's no CCP decision tree here, so we're going to choose a PRP, and this one is going to be like security maybe. We'll just go for staff training supervision. And then down here, adulteration employee. So that one's got employee training there, so staff training supervision. So next stage, we go to hazard management. And this is when we're getting into the details. So who's responsible for that? What's the critical limit? How are we going to monitor it? How often? Who's going to do that? What's the corrective action? Again, all of this is curated by AI, but you can add to it as you are working this through. So notice that only the significant risk came through to this stage, or the CCP list came through for the HACCP part, but all of the TACCP and VACCP side of things, they all come through because they're generally managed by prerequisite programs and other procedures and processes. So it's delivery here, and responsible person, corrective action, and so on. Please remember, if you've got any questions, to put them in the chat box. I will be getting to some questions in a moment. And then we've got validation. So validation and verification are two really important parts, not only of the food safety plan and HACCP, but in the updates to the new BRCGS Issue 9. And they also specifically say, well, we've got this validation here, industry knowledge, but they're looking for actual documented references as best practice for the validation to ensure that the control measure, critical limit, and monitoring procedure will work for that intended CCP. So you can upload external links, you can add documents, whatever it is that you want to do. And actually, it's not in yet, but we're going to be using AI to suggest various links for validation and so on there as well. It's the same idea here for the intentional adulteration side of things. Again, you would add in a validation in here, come through to the verification aspect now. Same idea here. We're going to say, well, how are we going to verify that? How often are we going to do it? And so on. And therefore, you're specifying everything out here. And then at some point, we'll be able to assign these tasks out to people in the task management system and also in the action management system within the software. So that's all fair and well, but quite a lot of work goes into that. Now, what if I want to use that same information in another HACCP study, for example? So we've got a concept of saving this as a model. I'm just going to call it high-risk chill food. What this is going to do is it's effectively going to take all the information that's saved in this process step and put it into a knowledge base, which means then that we can reuse that same information in another HACCP plan. Come out of here, and if I add in another step somewhere else, this happens to be in this same study, but this would work in any other study. And I'm just going to call this 3.1 post-production chill, for example. So I'm just going to edit that one. This is all blank at the moment. There's nothing else in here, but I'm going to download that model process step, which is here, and it will tell me what the scope is of that process step. If the scope of this HACCP plan is less than that, it will just use the elements that are relevant. So in this particular case, this is loading in the HACCP, VACCP, and TACCP of that model into this step. And I need to select some products in here that this step applies to. And then we go next to hazards, and you'll see that the hazards that we selected before, they're all there, along with the accepted risks for TACCP and VACCP as well, all the way through to controls, risk, CCPs, everything is there. So this gives us a really convenient way to be able to have standardized approach to particular process steps where we want to have the HACCP, VACCP, and TACCP information to be consistent across the whole food safety plan. So it's a big jump forward from just doing HACCP and then having your VACCP and TACCP systems elsewhere, or your food defense elsewhere in different systems. But it makes sense because, after all, these problems can and do occur during the process. And we want to look at all of the information as an integrated approach, taking into account raw material risks as well. So that's probably about as much as I want to cover today. So I know that we started a little bit late, and I want to try and see if anyone's got some questions. So I will stop presenting now, and we'll come over to see if there are any questions in the chat. Okay, we've got 6 here. Okay, Sue, I think you've been reading through these. Would you like to curate some of them for me, please?
Yes, absolutely. So we've got Jordan asking how flexible the system is for different industries, and also if the system needs programming or if it's simple to use straight from the off, essentially.
Yeah, so there are some aspects of configuration that definitely are going to be needed, because every food facility is different in terms of their approach, their processes, the risks that are involved. So, for example, with a little bit of training, you can set up the configuration of all of your risk assessments in the admin area of the system. I don't want to get too bogged down in all of that, but you can set up your own configuration. There's training materials on this, available on this, so you can set up your risk matrices, supplier risk scoring, all of these things, allergen lists, and so on. So everything in the system is configurable, and therefore it is available for lots of different types of scenarios.
Next question is regarding the use of ChatGPT and the validation of the information that it provides.
Yeah, for sure. So you'll notice that when we brought up the use of ChatGPT, we did have pretty relevant information that came back. We are still working on improving that. However, what we've discovered is that with ChatGPT, the important part is really about asking the question in the correct way and also providing it with some training data in advance. And because we've got lots of training data available in our system, we're getting very, very accurate results coming back. We still have to quantify that, but ultimately, it's like anything. It's all about how you ask the question and what context you put that question in. So this is the approach that we are taking. And we don't automatically just include any old information from ChatGPT, for example. To give you a bit more context on that, behind our system, we have a full AI control panel, which has nothing to do with ChatGPT. This is using our own AI tools. And what we want to do is we want to try and keep this usable for people so they don't need to be too worried about the intricacies of AI, for example. So we've already built the models in the background to go and get information and then surface it to you in a way that's already usable. So for example, acrylamide here, this is our hazard linking neural network in the back of the system. And what this does is it creates a graphical map of hazards, the operations they are relevant to, the possible causes of those hazards, controls, critical limits, monitoring, and so on. And so you can see this is actually a neural network map of information to do with acrylamide. And we can manage this. So we can add in additional operations. We can specify what the master hazard type and the low down hazard type is. So we're trying to keep all of this kind of away from you and quality control it in the background, so that if there's an issue with the data points that are generated by AI, then we can control that. ChatGPT is a different animal. That's someone else's technology. We're simply leveraging that technology because we're putting a bet on the fact that that's getting massive investment, and it does have, we've validated it ourselves so far. We've got more work to do on the likes of ChatGPT in terms of accuracy of data, but we're keeping the scope of that use fairly contained because we're looking for food safety hazards. We can check if it's a food safety hazard or not using AI itself, and then we're getting it to suggest possible causes and controls and so on. And we're just gradually working through that neural network map. But we already have a very significant database of all types of food safety hazards here and the different combinations of things that could go wrong, not just the food safety, but food fraud, intentional adulteration. And of course, that gets added to by just using the system, but so from people as well.
Okay, thank you. And one last question, again from Jordan. Has this been approved by GFSI certification bodies? And one from me really on that are, do you take into consideration other standards as well?
Yeah, so a system can operate to any standard, but GFSI accreditation bodies don't approve software. They approve food manufacturing facilities. And that's why BRC, for example, sold the BRC standard and it became BRCGS. That standard is now owned by a life sciences company. However, it still is a very valid standard, and it's a very high standard for food companies to operate to. But no, GFSI certification bodies do not approve software. They approve the content of the food safety management system. So I hope that answers your question, Jordan.
From my perspective, obviously today's focus has been on the GFSI, but thinking about other kind of standard requirements, SQF, etc., not just BRCGS, broadening that horizon as such and what is included.
Yeah, for sure. So at the end of the day, our approach is, when we started building out our system, we were focusing on BRC, as it was called then, I think issue 5 or 6 or something like that. That has evolved. The actual BRC standard, as I mentioned, was sold, and now BRCGS is buying up other standards. That's what's happening in the business world, plant-based and various other standards in there. And that's the model of their business. SQF and IFS and FSSC 22000 all take a similar approach, and that is, you've got to document your procedures, you've got to train your staff, you've got to audit it. It's all plan, do, check, act. It's standard quality type of approach. So what we do is we provide the tools that are really standard agnostic, but you can use them for any of those standards, thus the kind of flexibility.
Perfect, that's all the questions.
Okay, well, listen, thank you very much for everyone who stayed to the very end. I hope you found it interesting, and if you are interested in finding out more, please do contact us. You can email me on jf@primority.com, or Sue, who's our Director of Technical Services. Sorry, Sue, I forgot to introduce you earlier. You can email Sue on ss@primority.com. So thank you very much, everyone, and enjoy the rest of your day.